Dimitri is not here. Kendall, which property are you going to use to solve for y?
Opposite angles.
Perfect. If the opposite angles are congruent, Lewis M., what is y?
120.
120. Ding, ding, ding. Man, that was easy. The opposite angles are the same exact size and shape. Congruent, equal measures. So y is 120. Megan, what property? You don't have your family tree out. Okay. Julius, what property are we going to use to solve for x? Can't use opposite angles or congruent. We don't know the opposite angle. Ding, ding, ding. Consecutive angles are supplementary. Brett, tell me an equation I can write.
2x minus 7 equals 160.
That's skipping a step and everyone won't know what you did.
180 minus 120.
Okay, can I do this instead? Can I add them to equal 180? Because I think that will make more sense to everyone. Let's add these. But you did awesome, Brett. That's perfect. Add this plus this to equal 180. Because that's what supplementary means. Supplementary means they add to equal 180. But what Brett did was he found the supplement of 120. He just found it. What is it, Brett? It's just 60. 60, yep. So he knew that this angle had to be 60. If this one's 120, this one has to be 60. So he might have set that equal to 60. It's the same thing either way. Naja's not here. Melanie, what do you get for x? 60 plus 7 divided by 2. It's going to be a decimal. Ava, what'd you get for x? You're not doing it. Let's see, what'd you get for x? Where's your C? What'd you get for x? Go get your calculator. Tori, what'd you get for x? 3.6. Go get your calculator. Matt, what'd you get for x? 26.5? Okay. Kaylee, is that what you got? 26.5? Yeah, but you did press enter. 33.5. Oh man, first period. How many people did I have to call on to get that right? It's ridiculous. It's a Monday for me too.
And it's a first period.
It's a first period for me too.
We don't want to.
Okay guys, let's work this out because someone said, can we work this out? Let's subtract 120 from both sides because this is how Brett did it. Okay, so we agree that 180 minus 120 is 60. We know that this angle is 60. We know it's 60. So we've got 2x minus 7 equals 60. What's the opposite of minus 7? Plus 7. So we add 7. So we've got 2x equals 67. And then all you have to do is go to your calculator and do 67 divided by 2. Because the opposite of multiplying by 2 is dividing by 2. And the answer to x is 33.5. So moral of the story, Jeanette, what did we do to find x? Did we set it equal to something? No. Well, what equation did I make? How do we solve for x, guys? When you get a new problem and Ms. Tanton is not leading you in it, how do you solve for x? No. Step one. You add them. Kendall was trying to say, you add this plus this to equal 180 because consecutive angles are supplementary. They're not equal. You don't set them equal, the green ones. You add them to equal 180. That's one of your properties on your chart. Consecutive angles are supplementary. Okay, so here are some of the properties that we learned on Friday. I need, let's see, there we go. I need you to drag the word that describes the picture to the little box and it'll tell you if you're right or wrong. So Omar, go drag one. Austin, you're after Omar. John, you're next. Kenneth, you're after that. So these are parallelograms, possibly. And we're dragging the description to the property. Opposite angles are congruent. Try again. Like, can you drop it right in the middle of that box? Yes, that's a good job. Nice job, Omar. John, you should be ready to go. You're on deck. Austin's up. You should be ready to go. Opposite. You're going to use it again? Opposite angles. Can you ready? Diagonal bisect. Right in the middle. Yay! Good job. Nice job, Austin. Good, John. Can you go up there?
What is this?
Yeah.
Good. I just didn't know. Hey, let's not use one that we've already used.
No, I just didn't know what it
Three
said.
times
I just didn't know what it said.
Oh, okay.
Why do you go up there and do them, Julius? All right then.
Don't want to.
Try again. You don't have
This
to take it
game.
out. You don't have to take it out. Just leave it in there.
Oh, what did I do? I don't even know.
Okay, that picture. Let's work on that picture. Those tick marks, they don't mean parallel. What do those tick marks mean, John?
The congruence.
Okay, grab the one that says opposite sides congruent. Good job. Good. Try to get there. Let's go. We can't read half of them now. That's okay. There's two left.
No.
Not a parallelogram. Awesome job, Kenneth. Woo! And Shelby would be next, but she's not here. Paige, you're last. Hey guys, why is that one not a parallelogram? Do y'all know which one that is? What shape is that if it's not a parallelogram? You Where did that paper? Page it down. Page it down. She's like. Okay, so we are going to move on. This one is consecutive angles are supplementary because 120 plus 60 is 180. So here's what we're going to do now. Here's what we're going to do now. We are going to go to your family tree. We're going to go to where it says rectangle, and we're going to add 2 bonus properties for a rectangle.
I'm so lost.
Just ignore it. Brush it off. Brush it off. So, if you are a parallelogram and you get promoted in your job, you could become a rectangle. So if you're a special parallelogram, if you're really good at 2 things, you could get promoted. And we need to find out what those 2 things are for a rectangle. Take a guess, Torrin. I would love that. Well, we already have opposite angles congruent. What's special about a rectangle? It's not true for a parallelogram, but it is true for a rectangle.
All sides are
No.
That's a
Calm down, hey. Calm down.
I mean,
What am I showing in this picture right here? What am I showing? Brett.
All angles.
all angles are 90 degrees.
There we go. Teamwork. All angles are congruent, but more importantly, all angles are 90 degrees. So, you are a rectangle if you have 4 right angles. That is number 1 under rectangles. 4 right angles. You know where yours is, Tori? 4 right angles. Is there anyone family treeless other than Torin? I'll get you one if you can't find it, okay? We're not really going to talk about the golden rectangle. Okay, so we already did this. Property number 1, 4 right angles. Cool. Kaylee, what do you think I'm trying to show you in this picture for property number 2? Okay, we already know diagonals bisect, but you're really close. It is something about the diagonals. Yes! Ding, ding, ding. That is bonus property number 2. Not only do the diagonals bisect each other, but they're congruent. They're the exact same length. That does not happen in a parallelogram. It does happen in a rectangle. The diagonals are the same length. They're identical twins. So let me remind you, that does not happen in a parallelogram. Let's draw a parallelogram real quick. The blue diagonal is not the same length as the red diagonal. So those are not the same length, but when that parallelogram goes from slanted to straight, the diagonals automatically even out, and they're the same. So when it goes from diagonal to straight, your diagonals are perfectly equal. All right. We already know he has all the properties of a parallelogram. So a rectangle is a parallelogram, but he's a step above a parallelogram. Okay, now I need you to somehow find your notes from Friday. We did the front on Friday. We're doing the back today. They look like this. They look like this. If you can't find them, come get a whiteboard. If you cannot find them, you still have to do it. You don't get to just sit there. So go get a whiteboard if these are unlocatable. Like this. Okay. So you either have a whiteboard or you have your notes out. Here's example 1. What are we looking for? Are we looking for sides or angles? Are we looking for sides or angles here? Angles. So we need to be in angle mode. We're not sides, we're angles. We need to be in, triangles add up to 180. Oh, the angles of the rectangle should be 90. Yes, Ashley, you found it. Good job.
I sure do.
Alea, what's the measure of angle D? Yes, you do. It's a rectangle. And look at angle D. What's the measure of angle D? The whole angle, angle D. You found angle 1 for me. What'd you do? 90. Very good. So, one of our new properties in a rectangle is that all angles are 90. So when you get a rectangle, you are welcome to add 90-degree angle markings to every box. This is just how it's going to be every day. You're going to refuse to do everything. You're going to be on your phone. So, Alea, you did a great job. You got angle 1. How much is angle 1? How'd you do it? Perfect. 90 minus 20. Because the whole angle's 90 because it's a rectangle. And then we've already used up 20, so how many do we have left?
How the hell did she get 20? Oh, never mind. I see 20.
Okay. We are testy today. Catherine. Catherine, what do you think is the measure of angle 2? I'll give you a hint. Use alternate interior angles. Yeah, very good. I'm going to draw a Z. I'm going to draw the letter Z. In my letter Z, my alternate interior angles are congruent. That's old news. That's not new this unit. You already knew that. You could have solved for that one last unit. So there we go. And Ashley, what about the measure of angle 3? Here, let me mark this one. This one's 70. Let me give you a hint while Ashley's thinking. When you draw the diagonals of a rectangle, you get 4 isosceles triangles. So all 4 of these triangles are isosceles. Does that help, Ashley? If this triangle's isosceles? This is 70, so what's this one?
70.
If it's isosceles, it's 70 and 70. Now you can find angle 3.
40.
Yes, very good. 70 plus 70 is 140. 180 minus 140 is 40. Very good mental math, Ashley.
Thank you.
Okay, ready to go? Ready to move on, guys? Isosceles triangles. When you draw the diagonals, you get isosceles triangles. Don't forget it. Okay, I want you to try this one by yourself. Talk about it in a second. Sides or angles? Definitely sides. So don't think 180, don't think 90. That's off the table. It'll take some back and forth.
I'm already next to her. Much better.
Who's done? Are you solving? You can draw it. You can draw it. That's the only way you're going to get better is to practice. So we've got some properties. Kendall, tell me one property that we have that has to do with diagonals. Either from parallelogram or from rectangle. Diagonals are congruent. So I know once I find AC, that's the same length as BD. Lewis M., what's our other property about diagonals from parallelograms? About diagonals. Look at your family tree about diagonals. They bisect each other. They cut each other in half. So if AC has been cut in half, Megan, how long is AE? Okay, good. You found AC. What about AE? I was just asking the easier of the two questions. 8, yeah. Okay, so it got cut in half, 8 and 8. Well, the other one got cut in half too, and we just learned that if it's a rectangle, they're the same length. So what are these two pieces? 8, 8. That's not a coincidence. That happens every time in a rectangle. All those pieces are congruent. 8, 8, 8, 8. You're drawing this pipe? Okay, okay. So BC is what we need to find next. Well, that one's easy. Julius, BC. Easiest one on the board. How long is BC? Don't look at Torin. 10. What property did you use? Opposite sides, whatever. Okay. Opposite sides are congruent is the property he used. Awesome. Okay, Brett, what about DB? Ding, ding, ding. 16. And Naja's not here. Melanie, do you know DC? Is it a whole number or a decimal? Melanie, you're going to use someone's famous theorem. Whose theorem are you going to use? Pythagorean. So this AC is 16. So in your calculator, do 16 squared minus 10 squared. Why did I say minus? Why didn't I say plus? For a leg, not a hypotenuse. You're trying to get smaller, not bigger. Good. Take the square root of that. Oh, man. Just meant in context of it. What'd you get? 20? 12.4? 12.4. Ask me a question if you do... Okay. Ask me a question if you do not know where 12.5 came from.
I don't know.
We use, do you see this right triangle? It's red.
No, I'm looking at my shoe. Hold on.
We use that right triangle. And Kenneth, in that right triangle, we knew 10. And we knew, wait, how long is that? How long? 16. We knew those two things. Since we knew A and we knew C, we could do Pythagorean theorem, which looks like that, C squared minus A squared, and then take the square root. I'm going to move on. Next one on your sheet. Sides or angles?
Sides. No.
Both. Trick question. You're looking for sides and angles. All in one picture. Stop drawing SpongeBob. Erase it and got this problem.
Where's the angles?
So the first thing I recommend is that you mark your picture. ABE. ABE is 27 degrees. DB is 17. DB is 17. And BC is 8. So the first thing we're looking for is angle DAB. That one's easy. Ava, how many degrees is DAB? That green angle that I just kind of bolded, how many degrees is that? DAB, yeah, 90. Easy, easy, no math. What's wrong? Oh, you don't have those blanks? Do y'all even have this? Okay.
We have BC, DB, and BC.
Okay. It's okay. So I added some blanks. Sorry about that. Okay, so you have DC as one of your blanks. DC. Tell me how to set it up, Louis C. How would I set up finding this side right here? So I gave it to you.
Yep, it says for BC, they didn't
So you have to use Pythagorean theorem. Louis, would we add or subtract? We're trying to solve for this side of this black triangle. What?
I don't know.
So this is X. I'll redraw it. Sometimes it helps to redraw it because your picture can get kind of messy. That's 8, that's 17, and we need to find that. No, we're not doing trig. No.
Just making sure.
So it's either 8 squared plus 17 squared, or it's 17 squared minus 8 squared. We're going to add or subtract. Is this side, okay, what's 17? Hypotenuse or leg? So to find the hypotenuse, you draw an arrow away from the box, and you'll be pointing at the hypotenuse. So 17, a hypotenuse or a leg? Hypotenuse, very good. So when you're looking for a leg, you subtract, and when you're looking for a hypotenuse, you add. Is it a Pythagorean triple? Did you get a whole number? Torin, what'd you get? 17 squared minus 8 squared. How have you not even done it yet? Square root.
Wait, what?
Yay, it's a whole number. It's a Pythagorean triple. 15. All right, and then Matt, how long is EC? It's a decimal. Diagonals bisect each other. What'd you get? 8.5. Very good. Jeanette, how did you get 8.5? Where did that come from? Diagonals bisect each other. Split what in half? What do you split in half? The what? Okay, what number do you split in half? 17! Yeah! The diagonals cut each other in half, so cut that number in half. Cut the diagonal in half. You said y'all don't have those angles, so we'll move on. We won't do the angles. All right, let's move on to rhombus. Rhombus is next. So go back to your family tree. Do you get this? Do you get this cartoon, guys?
No.
A rhombus, like a school bus, shaped like a rhombus. Huh? If you've ever owned anything with an argyle pattern on it, you have worn a rhombus. Argyle.
Don't look at me. I don't have one.
This bracelet, and it pretty much a rhombus. When you think of the word diamond, that's a rhombus. The shape of a diamond is a rhombus. Diamond shape. So what is a rhombus? What is a rhombus? It's a shape, a diamond shape. What is special about it?
It's not a shape.
What? All of its sides are equal. Not just opposite sides, but all of its sides are equal. So a rhombus is a parallelogram with 4 congruent sides. I have his property, oh wait, I have the property on the next slide. So when a square met a triangle, they had a little baby and they called him rhombus. Because it's like a square, but it's leaning over. It's like a leaning over square. It's cute. I don't know. Property number 1, all sides congruent. Not opposite sides congruent, all. 4 sides are the same exact length in a rhombus. Are the rhombus's angles 90 degrees? Are these 90? 90, 90, 90? No, he's a square leaning over. So his angles are not 90. But, what am I trying to show you here? What is that? What's that? Not vertical angles. What are those dotted lines called? The diagonals are, they're not, a diagonal can't be 90. A segment can't be 90. They are, Omar! They are perpendicular. Very good. The diagonals are perpendicular. A rhombus is a little bit more special because he gets 3 bonus properties, whereas a rectangle only got 2. Good job, rhombus. So let's find out what that last one's going to be. Last property of a rhombus. Ooh, what am I showing there? Nope, we already know opposite angles are congruent. That's old news. This has to be new. What are those dotted lines doing to those angles?
Bisecting.
So what is bisecting? What are the dotted lines called? The diagonals bisect the angles. Diagonals bisect the angles. Write it down, Megan. Write it down. This is property 3. Diagonals bisect. You can put opposite angles or you can just put angles. The diagonals bisect the angles. So the angles get cut in half. Okie dokie. Artichoke. Let's try them. Oh, sorry. Last one is a square, but you notice, wait, there's no blanks to write under a square.
Nothing to know about it.
Very good. So a square is a parallelogram with 4 right angles and 4 incongruent sides. So if you're if you're a parallelogram and you get promoted to a rectangle and you get promoted to a rhombus, then you can go on and you can become a square. So square is like a rectangle and rhombus all in one. 4 right angles, 4 congruent sides. A square has all the properties of all of the ones above him. So how many properties does a square have? If he has all of these, how many?
10.
He has 10 properties. A square has all of them. He's the envy of everybody. Everybody wants to be the square. He's the coolest. Quad on the block. Huh. Okay, go back to your notes. Put yourself in a way, Ashley. Go back to your notes. What is that? A square, a rectangle, a rhombus? What is that? It is a rhombus. Notice how I almost spelled rhombus with the letters. Rhomb. Okay, Herb, HRB. Herb is 40, so label it 40. We're almost done, guys. Don't worry, we're almost done. Whoa, I only gave you one angle, and I'm expecting you to find all those other angles. Let's use one of our new properties right away. Let's use it. The diagonals bisect the angles. So what else can I label 40? Okay, alternate interior angles, but that's not using our new property. This angle got cut in half. If half of it's 40, then the other half is 40, 40, 40, 40. That's the first thing you can label. 40, 40, 40, 40. Let's use another one of our new properties. The diagonals are perpendicular. Omar, what should I add to my picture if my diagonals are perpendicular? What symbol? Right angle. Everyone add a right angle. All 4 of those are 90. 90, 90, 90, 90. Add right angle. Okay, we only have 4 missing angles, and they're all the same measure. We need to find these angles. We need to find those. So what we're going to use is a right triangle. You see that right triangle? How many degrees are in a triangle? 180 minus 90 minus 40. Go. 180 minus 90 minus 40. Austin, what do you get? 50. Okay, we know all of them. 50, 50, 50, 50. Yay, we know all the angles. Let's just make sure we know how to name these correctly because I'm a little worried about that. John, what's the measure of OBH? It's already labeled. You just have to find the right one. What's the measure of OBH? O to B to H.
I'm sorry, I blinked out the whole time.
You blinked out the whole time. Okay. Start here. Go to B and go to H. This angle. How much is that angle? I've already marked it. 90. Kenneth. MRO. Angle MRO. Rho. Huh? Oh, how much is it? What's the measure of it? Look at the picture. M to R to O.
Oh, wait, is it 40?
It's 40. It's already labeled. I'm just making sure you know how to grab the right angle. And page BMO. BMO. 50. Okay, can we move on? Let's move on. Rhom is a rhombus. Angle ORH is 3x, and ORM is 75. Am I going to add those to equal 90? Am I going to add them to equal 180? Or am I going to set them equal to each other? Because those are my only options. And the reason I'm going to set them equal to each other, what property?
Diagonals bisect.
Very good. Because the diagonals bisect, I know that these angles are identical twins. Twin, twin. 3x equals 75. They're equal because that diagonal got cut in half. What? X is 25. Thank you, Julius. 25. ROH. This angle right here. Well, wait. If that angle is 75, then that angle is 75, and that angle is 75, and that angle is 75, because the opposite angles are congruent and they get cut in half. 75. 25 is x, so be careful. It's not the angle, it's x. And then RHO. Uh-oh. How do you find that one? It's not 75.
Right. Add a.
What's this? Yeah, what's this whole angle? Let's just find out what that whole angle is. 150. We go back to parallelogram properties. These are not opposite angles. These are consecutive angles. What are consecutive angles? Supplementary. 180 minus 150. Yay! Is that okay? That last thing? Is that okay? Consecutive angles are supplementary. These add up to 180 always, whether you're a rectangle, rhombus, square, parallelogram, every time. Okay, the only one we haven't done an example with is a square. So let's do a square. Square. Are those sides or angles? Sides. Kaylee, what should we do with x plus 1 and 6x minus 9? Huh? You know? Yeah, let's write an equation. What should it be? Equals. Equals. There we go. If it's a square, all sides are congruent. So they equal each other. 6x minus 9 equals x plus 1. 5x equals 10. X equals 2. Alea, how long is one side of that square if x is 2? 3. 3, 3, 3, 3, because it's a square and all sides are congruent. So, Catherine, the perimeter is? Huh? 12. Awesome. And last thing, Ashley, AD. The last thing. Just tell me how to set it up. You don't have to solve it.
I have no idea.
Oh, okay. Thank you for being honest. Dimitri's not here. Kendall, how do we find AD? Pythagorean theorem. Tell me what to write. Very good. Everyone do that. 3 squared plus 3 squared. Then take the square root of it. 3 squared plus 3 squared. 9 plus 9 was the square root of 18. And that is the answer to AD.
Yep.
Okay. Lesson's over. Now you get to practice me. I'll come get your warm-ups. Gather your warm-ups in your new group, please. I'll come get them. Okay, warm-ups.